So in this section, we are going to look at troubleshooting the electric motor with the digital multimeter. So like we have always emphasized, you're appreciating the composition of the equipment that you are testing, okay, as regard the constituent components and how these components interact to make your equipment function properly is very, very important. That's your knowledge of how they operate is very, very important. Okay. So before we go into the use of the digital multimeter in troubleshooting your electric motor, let us appreciate the electric motor. Okay. But you can also watch our training on electrical machines where we actually treated the electric motor in details. But let us look at the electric motor composition. You know that all electric motors, they have windings in them, okay? And these windings, if it is a three-phase motor, these windings, they are wound in three-phase beds, okay? One to each phase. And as you can see on your screen, these windings, they are placed in what is called the slots, okay, in the stator. And if you look critically, you will see that the winding, they are insulated from the stator core, okay, as you can see. So those insulating materials, which insulating lead rod or whatever insulating material that is used, its purpose is to insulate this winding, okay, from the core of the electric motor. And also too, each of the phases, they are insulated from one another. That is, they don't have any electrical connection with, that is interaction with one another, except at the point that you deliberately made those connections, okay? Now, we all know how the electric motor functions. We know that as you supply power to the electric motor, those windings, since current will be flowing through them, magnetic field will be created. So since each of the phases have the same number of turns of the same wire gauge, that is the size of the wires used on all, they are the same, okay? And then the number of turns in each of the windings, they are the same. So which means that the magnetic field strength on each of them is expected to be the same, okay? Now, we know that the major active component in the electric motor are these windings. And these windings, they don't have any interaction with one another, each of the phase winding, except at the point you deliberately make those connections. Then again, too, the winding does not have any connection or interaction with the yoke, that is the frame of the electric motor, okay? So now, what are some of the major faults that you could experience with the electric motor? So some of the faults that you will experience with the electric motor is the shorted windings or turn to turn and or turn to ground shorting, okay? Now, when we say shorted winding, what do we mean? We know that when you are winding the motor from start to finish, okay? So you expect that whatever current that is flowing through that electric motor, that winding, should only have access out at the finish point of that particular winding. So maybe due to imperfection or due to operational problems, there may be breakage in the insulation. This insulated copper wire, this copper wire that you are seeing, they are all, it is insulated. Each strand of it is insulated. That is why it is called insulated copper wire, and that is what we use in doing our rewinding. So that insulated copper wire, whether they are on each other, doesn't matter, because they will not make contact with each other because they are insulated. Okay, so since they are insulated, they don't have any connection. But if there is any breakage in that insulation, okay, then we may not have what is called a turn-to-turn short. And once there is turn-to-turn short, you know, electric current, they prefer to go through the less resistive parts. Okay, so instead of them running through the entire windings, they will prefer to go through that short, okay, and then short circuit the flow of electricity through that particular winding. And the implication is that the magnetic field that is expected from that winding, okay, will not be generated. And if that is not generated, you see that there will be unbalanced forces on that particular phase beds, okay. The others, they have their normal magnetic field force flux, and this one have a shortage, so the force exerted by each of these poles will be different. And once they are different, that can cause rubbing of your rotor and further aggravate the problem with the electric motor. So turn-to-turn short is something that is not desirable in your electric motor. Then apart from that, it also has some safety implications, okay? Because turn-to-turn short can cause arcing at the point of contact, at the point of short, and then eventually it can lead to burning, and eventually that will lead to other catastrophic problem downstream or upstream the electric circuitry. Now, apart from turn-to-turn short, we also have the possibility of it shorting, the wine is shorting to ground. So now if you look at this, the insulated copper wire that is used to make each of these windings, these phase windings, you will see that they are insulated from the yoke of the motor. You see the insulating lead, the insulating material that is used to insulate the windings from the yoke. So you don't expect this winding to have any connection with the frame, okay, or the yoke or the body of the electric motor. But if there is failure in any of this insulating material, or failure in insulation of the material used due to maybe overheat, short circuit within the slot, okay, that can cause failure in those insulating material and eventually cause turn to ground short, okay. And once there is turn to ground short, of course, it has a safety implications, because the personnel that is working on it will be exposed to a shock hazard, okay. And apart from that also, as we earlier said, the electric current, they prefer to run through the less resistive part. So if that is the case, that you have turn to ground short, what will happen is that the electric current that is expected to flow through the winding will prefer to flow through that point of short to ground. So if that happens, the case that we earlier explained will be the case of that particular electric motor. So it is an undesirable situation, okay? Then another problem that is common too is the open circuit in the winding. Remember, the current that is flowing through the winding is expected to go all through the course of the winding and then out, okay, to the finish terminal from start to finish of the winding. But if there is an open circuit, it means the winding is not complete, okay? So that magnetic field, there won't be flow of electricity. That magnetic field will not be created and the motor will not work. If it is in the case of this three-phase motor, if it is one phase that is open, then we may have the case of a single phasing of the electric motor. I will know it is a real problem to the electric motor circuit. Okay. Then that is the second problem that is common with the electric motor. Then the other problem is the burnt winding. Okay, maybe due to overload, sustained overload, the the windings are meant to withstand current that is beyond the capacity that it can hold. That can cause it to heat up and eventually it will burn. The insulations around the insulated copper wires will fail, and that can even affect the insulation between the yoke itself, okay, and the windings. So that burning of the windings can also cause serious problem as we outlined, those problems that we outlined before. Even if the motor is working, okay, you'll see that it will be consuming excessive current that may even cause further damage on your supply cables. So all of these are undesirable situations that we actually do not want in our system. So how do we use the digital? Because these are the three most common problems that you see around the electric motor in the field. So how do we use our digital multimeter to test for these problems, okay, if they are in our motor? That is what we actually want to see now. So now, the tests that you carry out on the electric motor, they are all dead tests. That is when the motor is inactive. Okay, remember, you tested the control and the power circuit to the point of the motor and have confirmed that the power circuit and the control circuit, they are okay. Now, you have been able to identify that the problem is with your electric motor. Okay, so there are a few tests that you can do right there in the field, and there are some, once you have ascertained what is the problem, that you now need to lose that electric motor and take it to the workshop to carry out further tests and then maintain the electric motor accordingly. Okay, so now what you need to do first, remember it's a dead test, you need to disconnect these shunting bars on this electric motor. Okay, remember that your electric motor, all the electric motor, like we said earlier, they have three phase windings in them. Okay, and that is what we are seeing here. We have the U phase, the V phase, and the W phase. So in the winding, you know, in rewinding, you have to start from somewhere. So the start of that winding, okay, is what is labeled the 1. And then the finish of the winding is what is labeled the 2. So when you look at the terminal block, you see that you have U1, U2, V1, V2, W1, and W2. Okay, so all the ones are the start of the windings, each of the windings, and all the twos are the finish of each of the windings. So when you want to start, that is, you want to connect the electric motor, you can either connect it star or you connect it delta. Okay, so when you connect all the twos or all the ones, okay, that is starring the electric motor. As you can see here, all the twos are connected. Then when you connect U1 to V1 to U1 to V2, and then V1 to W2, then W1 to V2. Okay, that is data connection. Okay, so those are the two connections, type of connection that you can do on your electric motor. So before you carry out your test, all these shunting bars, which are these, okay, whether you are data connected or star connected, you will disconnect them, and then you have something like this. Okay, so you can see, so as you can see, this is a V2, this is W1, okay, this is a this is U2, okay, and this is U1, this is V1, and this is V2, okay. So that is it. So now what you want to do now is to test each of these windings, okay, whether any of them is shorted within or any of them is shorted to the ground. That is one test that you want to do. And then you also want to check for open circuit. So now if the winding is shorted to ground, okay, you can actually carry out your continuity test while you have all the shunting bars on. Okay, so you just to take your meter to your continuity selection of your digital multimeter, and then place one probe here on the terminal of the cable of the motor, and then the other terminal to the frame. So if any of the winding is shorted to ground, you will hear the beep, since all of them are connected, as you can see on the shorting bar. Okay, so when you disconnect like this, you actually want to see which particular winding, whether it is the U, V, or W winding that is shorted to ground. Okay, now this is what you do. You test the W1, W2. Okay, let me use this part. You test V1, V2, okay, to confirm that it is continuous. So if it is continuous, you will hear the beep, and then you can take, since this is open, like it's open already, okay, let's say we are using this U1 now, okay, so you take U1 and U2, okay, you take U1, U2, so when you test U1, U2, it is expected for it to be continuous, and then you leave one of the probe either at U1 or U2, and then take the other probe to the ground or the body or the frame of the motor to see if it is the U phase that is shorted. Okay, so if there is no beep, it shows clearly that that winding is not the one that is shorted. Okay, but if there is a beep to ground, it shows that it is shorted. So testing between U1 and U2 will show that it is continuous. Then U1 and ground shows that the U phase is not grounded, okay, if you did not hear that beep. So you continue for V and W, okay, to ascertain which of the winding is actually causing the problem, and also know which of the winding is open. So what you do first, you see the digital multimeter, you switch it to the home or continuity selection of your multimeter, as you can see. Okay, so it's now on the continuity. So you take your probe, the red probe, to U1, and then take the other to U2. So that way you will hear, if it is continuous, you will hear the beep. But if it is broken, that is, there is an open circuit in that winding, you will not hear any beep. You will see an overload, okay, telling you that the circuit is open. So you immediately know that that U winding is faulty. So if it is okay, you will hear that beep. Remember, you are testing continuity. Okay. Then you will do the same for the U phase, okay, which is V phase, I mean to say, that is between V1 and V2, and then finally between W1 and W2. Then you will take U1 to ground to show if it is shorted, then V1 to ground to show if the V phase is shorted to ground, and then W1 to ground. Okay, that means this red probe will be on one of the terminal, or you can put one of the terminal if you are testing to ground, one of the probe permanently on the frame of the motor. Then you take the red probe to U1 to test if U1 is to ground, to U2 to test if, to V1 to test if V1 is to ground, and to W1 to test if the W phase is to ground. Okay. Then the turn to turn short. Remember we said earlier that these windings, you don't expect them to have connection with one another, which means that as you have removed those shunting bars, if you read continuity between U1 and V1, you will not have any reading to show you open circuit. Okay. Then U1 and W1 and V1 and W1, you are not supposed to have any reading at all. So if you have turn to turn short or short between the windings, okay, if you test between U1 and V1, you may have a beep or it may show continuity. That is to show that there is a short between those phases, between U and V. If it is between V1 and W1, if there is a beep, it shows that there is a short between the V phase and the W phase windings. Okay. So, and those are undesirable conditions. So once there is something like that, it is now left for you to know that you know that definitely the electric motor needs repairs. Okay. You have to fix those windings. Then burnt winding. Burnt winding could be evident. It could be evident when you open it up like this and then inspect the motor. You could see the burnt, okay, around the winding. But there are some that will happen in the middle of the slot that may not be too visible. Okay. But once those windings are burnt, it means that at that point of blast or burnt, it is either the windings may have been shorted at that end, or it may open up the circuit. Okay. So whatever the case, if it opens up the circuit, probably it did not, the heat was not strong enough to break the insulation between the winding and the yoke. So you will not get winding to ground reading because of that. Okay. So, but you can carry out resistance tests. When you carry out resistance tests, and you will use a different meter, not this one now. Okay. The milliohms meter. Okay. We have another training on measurement, electrical measurement and testing. Okay. So you can check that training out, where we discuss how to use the mega meter, the mega ohm meter, the milliohms meter, the hypots testers, just tests like the insulation resistance test, the dielectric absorption test, dielectric absorption ratio test, the polarization index tests, and others they are discussed in that particular training. So you can check that training out. Okay. So you test for the resistances of each of the winding. Okay. So if you are testing the resistance of the U phase, you test between U1 and U2. will give you the resistance. V1 and V2 will give you the resistance of the V windings. W1 and W2 will give you the resistance of the W winding. So since the three-phase windings, they are exactly the same, expectedly. You are supposed to have the same resistance in each of the windings, okay, in milliohms, okay. So, or a million, it depends on the size of the motor. Smaller motors, you can have it in ohms, okay. So, they are expected to be of the same value. So that one that is shorted within, burnt inside, you see that the value will be far, far reduced, okay, because it has been burnt and shorted within. So all of those will give you an idea as to the condition of the electric motor. So when you notice any such thing, definitely that motor, the solution to it is repair or complete overhaul. Okay, so still on the electric motor circuit, we have discussed earlier how to troubleshoot the electric motor circuit. Okay, so let us just explain a little on this one that is a little bit more complex than the one we observed earlier, in the sense that we have more components in the system. But if you look at this, we have on the power line, we have from the input into the system, okay, we have the fuses. That's the first component we come across. Then we have the contactor, and now we have the overload, uh, the overloads, okay, that helps us to protect the motor against sustained overload. Okay. Then on the control side, we also have the transformer that is feeding the control circuit. You see that we have an additional component, the fuse. We have the stop push button. We have the start push button, the retainer contact. Then we have the contactor coil. Okay, that's the coil that is that the coil that is operating this contact. Okay, then we have the overload contact, which is tied to all of these overload. Okay, so now you can troubleshoot this circuit live or when the circuit is dead, as we earlier explained. Okay, so the explanations, they are basically the same. Okay, they are basically the same. The additional components that is there, basically you test for continuity, and then when you do your AC voltage test, you test for the before the component, whether there is the voltage signal, and after the component, whether there is a voltage signal. All of those will help you to zero in on whichever component that is causing or that may be causing the problem.